if we graph x minus 3 squared from 0 to 4, so x minus 3 squared, and then let's just look at this from 0 to 4. So I'm going to cut this off 0 less than x less than 4. There. I guess it'd be or equal to. Yeah. It's pretty cool, isn't it? All right. So what we're looking at is like we've got the point 0, 9, and we've got the point 4, 1, or our endpoints, right? So what it's telling us here is that slope between the endpoints, which would be 2, negative 2. So we would have y equals negative 2, x minus 4 plus 1. So if we look at the slope between the endpoints here, we have to have the slope of a tangent line somewhere that is the same. So like I could think about this, y equals f prime of, let's see if it'll do this. I think it will. It's x minus 4. No. A plus f of a. Okay, let's see if this works. I think I need to change that to a as well. Okay. Yeah. Okay. Let's see if it works with the slider. Oh yeah, that works. So what we're saying is that this is continuous, it is differentiable. So somewhere along here, there has to be a point where that slope between the endpoints is equal to the slope of the tangent line. So if I'm just trying to guess at it, right there, it looks like it's probably 2, right? That looks like those lines are parallel for that. So this probably, though, would not be on a calculator active question. I think it's helpful to look at it, but it would probably not be on a calculator active problem. So what we would have to do for this, for the mean value theorem, first of all, we could say f of x is continuous and differentiable. Because it is quadratic. And quadratics are just continuous and differentiable everywhere. So, oh, yeah, good call. Because f is quadratic, yes. Did you lose points for that yet, or was that?
I have.
Yeah. There was one of you that said it that did not lose points because you would assume that it meant f in that scenario, but it was still dangerous. So it's best just not. Like this would be, like that it right there, I don't think would actually lose points on the AP exam because there's nothing else that it could really be referring to besides the f at the beginning of that sentence. But it's still dangerous. Just don't, if you see yourself writing it, just don't write it. Write the name of the function instead. So f of 0 would be 0 minus 3 squared, which would be negative 3 squared, which would be 9. So we've got the point 0, 9 is one of our endpoints. And we would do the same thing for 4. So 4 minus 3 squared would just be 1 squared, which gives 1. So we got the point 4, 1. So those are the points, coordinates of our endpoints. And if we don't have a graph, we can just plug in our x values to find the y values. And so our average rate of change of f on 0, 4 would be just slope formula, 1 minus 9 over 4 minus 0, which would give you negative 8 over 4, which is negative 2. So f prime by mean value theorem f prime of c equals -2 for some c on the interval from 0 to 4. Now, I'm not done here because this particular question wants the c. It wants to know what that c is. So, mean value theorem guarantees, here's my endpoint, here's my other endpoint, and average rate of change is the slope between the endpoints. Mean value theorem guarantees that the derivative has to equal -2 somewhere on 0, 4. Now, how are we going to find that value?
Would we find the derivative of f of x and set that equal to -2?
Yes, exactly. So we will find f prime of x, which is going to be a chain rule here. So it's going to be 2x minus 3 to the first power. We would multiply that by the derivative of the inside, but that would just be 1. So really this is just going to be 2 times x minus 3. You could distribute the 2 if you want. It doesn't matter. Either way. And we're going to take that derivative, 2 times x minus 3, and we're going to set it equal to -2. And so you could distribute or you could divide. It doesn't matter. I think I'll divide. So x minus 3 equals -1. Add 3 to both sides. X equals 2. I guess actually really what I probably should have done there, the best way to have done that is to right here use a c instead of an x because it's asking you to find the c value. You'd probably be okay just to say, therefore c equals 2 at the end too. And so that is just the point where the derivative and the slope between the endpoints are equal to each other. There. And we can see on our graph that looks about right. That looks where those, like where those two lines would be parallel. Okay, questions? All right, let's do some more. All right. So, given f of x equals 5 minus 4 over x, find all values of c in the open interval from 1 to 4 such that f prime of c equals f of 4 minus f of 1 over 4 minus 1. Now, this particular problem says nothing about the mean value theorem, right? But it is asking you to use the mean value theorem because you're looking at the interval from 1 to 4. This is the slope between the 2 points at x equals 1 and x equals 4, and it's equal to the derivative. So it's asking you to find that c value. You would, first of all, need to make sure that the mean value theorem applies. So this function, I would rather write it like this. Typing it is a little harder. I'd write it like this, 4 over x. Is that function continuous everywhere? No. Where would it be discontinuous? At 0, right? X cannot equal 0 for this. So that could be a problem for us. But what interval are we looking at? 1 to 4. And so that's not on the interval that would cause us an issue, right? F of x is continuous and differentiable everywhere except at x equals 0, since 0 is not on the interval.
You have to say that because you just say it's continuously differentiable.
You're probably okay with continue. Yeah. The thing I like about wording it this way is you're acknowledging like that there is a discontinuity, but it's not on that. You could probably get away with just saying it's continuous and differentiable from 1 to 4. Since 0 is not on the interval from 1 to 4, mean value theorem applies. Okay. So what we need to do is we need to find the slope between the endpoints. And to do that, we need to know the endpoints. Ethan, what are we going to do to find the endpoints?
You gotta set it into f, like do f of 1 and f of 4.
Very good. So we'll do f of 1, which will give us 5 minus 4 over 1, which is just 5 minus 4, which gives you 1. So we've got the point 1, 1. And then we need to do that same thing with 4. So that will be 5 minus 4 over 4. And that'll be 5 minus 1, which gives us 4. So we've got the point 4, 4. And so we need to find f of 4 minus f of 1 over 4 minus 1. So that would be 4 minus 1 over 4 minus 1. We will get 3 over 3, which is 1. This is our, I'm going to do this. Don't do it on a free response question. Average rate of change on 1, 4. Write it out on, if like, especially free response test or quiz. Write it out. But we'll be okay here. So average rate of change on 1 to 4 is 1. So the mean value theorem tells me that therefore f prime of c must equal 1 at least once on the interval from 1 to 4. And this problem, like the other problem, wants us to find that c value. So f of x is 5 minus 4 over x, but that could also be written as 5 minus 4x to the negative 1. That will be easier for us to deal with if we need the derivative, which we do here. So f prime of x. Xander, what will we get when we take the derivative of that?
Negative 1 times 5 minus 4x times negative 4. Oh, 5 minus
no.
4x to the negative 7. Oh.
No. What's the derivative of 5? It will just be 0. So this one's not one that needs like a chain rule with it because it doesn't have like a set of parentheses around it. So you're just taking the derivative of 5, which the derivative of 5 would be 0 there. And then you're using the power rule on that second part. So what will we get when we just use the power rule on that part, Xander? Very good. And if you want, you can write that as 4 over x squared there. So f prime of c would be 4 over c squared, and that has to be equal to 1. How do I solve that? Multiply by that c squared because you can't solve for it while it's in the bottom. Right, so that gives you 4 equals c squared. What do we do now? Square root both sides, which technically gives me plus or minus 2, but is negative 2 on the interval that we're looking at. It is not. So we would just say C equals 2 for that. Okay, questions? So if you kind of look through the steps whenever you have a problem like this, the first step right here is continuous and differentiable. This right here is your second step to find endpoints. The third step right here is your average rate of change. And then fourth step would be your conclusion. Saying that there has to be a point there. This last step, this part right here, is not always necessary. Find the C. It would be your fifth step if it asks for the C. Sometimes it just asks you to prove that it has to happen, but sometimes it'll ask you for what the C is. Okay. All right, so sometimes they'll give you table problems where you don't really have an equation. So the table below shows certain values for f, a continuous function. Is there an x value on the interval from 0 to 10 such that f prime of x equals 1/2? And I can't remember if I did this on purpose or not. Any ideas on the answer to this question? There's kind of like a problem here. And I can't remember if I did it on purpose or if I was just careless. Does the mean value theorem apply to the situation? It does not say it's differentiable. Mean value theorem does not apply to this situation. I can't remember if I did that on purpose or not. I can't remember if I did it trying to trick you guys so that you notice it, or if I was just careless and did not include it. So, as it is written, you would not be able to answer this question. You would, like, if sometimes they'll do something like this and say, like, one of the answer choices will be, there's not enough information to determine, would be like your answer choice, and you would choose that one if it looked like this. I think I was probably just careless here. Let's put and differentiable function here. So let's say that it is differentiable. If you're answering it and it's for response, yes, you still have to state it. What you would want to say is just since f is continuous and differentiable, mean value theorem applies. And so, f of 0, what is it? It is 5, so we got the point 0, 5. What is f of 10? 10, so we got the point 10, 10. Our average rate of change on 0, 10 would be 10 minus 5 over 10 minus 0, which will give me 5 over 10, which equals 1/2. So since my average rate of change is 1/2, is there an x value on the interval from 0 to 10 such that f prime of x equals 1/2? Yes. So, so we would say, therefore, I like to just restate what the problem asks you. There is an x value on the interval 0 less than or equal to x less than or equal to 10 such that f prime of x equals 1/2. Now, this problem does not ask us to find the c, nor would we be able to because we don't have the equation for it. So this would be where you would stop here. So you can see those same steps. Again, you've got to state that it's continuous or differentiable. You've got to find your points. You've got to find your average rate of change, and then you can make your conclusion, right? So continuous and differentiable, endpoints, your average rate of change, and conclusion. And a lot of times if you find these on like the free response section, and they're on the free response section pretty frequently, your conclusion is just you like rewriting what the question was asking. Like, yes, there is a value. I like to use their exact words. There's other ways you can word it. You could put it in your own words if you want, but you know if you just copy their words right back to them, that you won't mess it up. There. Okay, questions? Okay, so for this one we have a graph instead of a equation, and I'm going to zoom out just a little bit. What is the average rate of change of f on the interval from 1 to 5? It would be 0. You could use your points, but right here is at 1, right here is at 5. What is the slope of the line between those endpoints? It is 0. So you could just say 0. You wouldn't necessarily have to show work for that. Okay? Now, how many times on the interval from 1 to 5 does the average rate of change of f equal the instantaneous rate of change of f? Now, average rate of change of f, that is the slope of that blue line I drew in. Okay? Instantaneous rate of change of f, what is that? Is your derivative, which is your slope of your tangent line. How many times is my tangent line going to be a horizontal line here? 3 different times. It happens right here at that maximum, right here at this minimum, and again right here at that maximum. So it would be 3 times. Okay. This is a special case that has its own special name. I think it's Rolle's theorem, R-O-L-L-E theorem. But it's just like a special case of the mean value theorem. So, so it will work. Is that right, though? Or is Rolle's theorem for zeros? Don't quote me on that. I might have to go back and look it up. Okay? All right. So, your assignment.